Hey everybody, logarithmic functions, and we're looking at just being able to solve the different types of logarithm, logarithmic functions we'll have in our homework. Solving logarithms is not difficult. What's difficult about it is that the numbers are, I'll call them jumbled. They're not straightforward like we're used to seeing. And that's the most difficult part with logarithms. But it's actually easy if you just remember one thing: the base. You should know the base in an exponent is whatever you're taking to a power. That's your base. So whenever I see, for instance, log base a of x, what it's saying is the power to which you raise a. Here, I'll even make sure I put that in red. The power to which you raise a to equal x. And what that simply means is a to the m, some power. I don't know what it is. So a to the mth power equals x. And that's what we're doing. Is we need to take this log function and rewrite it as an exponential function and then be able to solve. So I have some examples here. Log base 3 of 27, which simply says the power you raise 3 to equal 7. So I would write 3 to the m equals 27. And then I need to figure out how many times is 3 times 3 equal to 27. Well, it is 3 times. 3 times 3 times 3 equals 27, so 3 to the third. So log base 3 of 27 equals 3. Another example, log base 2 of 64, which simply says the power you raise 2 to equal 64. So I would write 2 to the mth power equals 64 and figure out what power do I need to take 2 to equal 64. Well, 2 to the sixth power. 2 times 2 times 2 times 2 times 2 times 2. I think it's 6 2's. Will equal 64. Okay, now here's one that's a little backwards. I have log base 16 of 4. And what this says is the power you raise 16 to equal 4. So that is 16 to the nth power equals 4. So what power will I raise 16 to equal 4? Well, to the 1/2 power. Or I'll write it like this also. 1/2 power is the same as the square root of 16. So what I would like for you to do is pause the video, and you have two problems here that I would like for you to look at, and let's see if we can come up with the same answers. Alright, so the first thing that I do is I take my base and I write my base. And then what I'm trying to find is the exponent. And then the of portion, log base 8 of 2, that's going to be my answer. Now I already have everything written out here. So what I'm saying is that the base, the exponent, this what you equal from a log is your exponential power, exponentially written, equals 2. So what this says, and I'll write it like this, is the cube root of 8 equals 2. Or 8 to the 1/3 power equals 2. Again, the first thing I start with is my base. I find the base in the logarithmic expression. I make that the base of my exponential. I know what the logarithmic function, most often what I'm trying to find, is my exponential power. It equals the of portion. Log base 7 of 1. So what I'm looking for is to what power can I raise 7 to equal 1? Well, that is going to be 7 to the 0 power. Anything to the 0 power is equal to 1. So with this, we can see that a logarithmic function is simply can be simply written as an exponential function, and we should, for the most part, be comfortable with our exponential functions. So I can take a logarithmic function and rewrite it as an exponential function. The key is identifying the base, writing the base, knowing that my answer is going to be the y value, or m is what most books will write, and then you have x as being what everything is equal to. So let's look at some problems with this. And here's a couple of things to just be able to look at. Log base a of 1 equals 0, because a to the 0 equals 1. And these will fall true for whatever you plug in for your value of a. And log base a of a is equal to 1, because a to the first power is always a. Alright, so example, convert to a logarithm. So given this exponential function, write it as a logarithm. Well, first thing I know is going to be log, so I write down log, and then I know my base of that log. That's the same as the base of the exponent, and then whatever it equals, that's going to be my x. So log base 5 of 125 equals t. And the whole point of this is just rewriting this as a exponential or logarithmic function. So 10 to the negative third, which equals 0.001. So my base is 10, and my exponential power is a negative 3. So I simply say log base 10, what does it equal? Up here, 0.001 equals my exponent, negative 3. So I would like for you to pause the video, and I would like for you to work 3 and 4. Alright, for this one, the first thing that I do is I just go ahead and write this. I know I'm converting it to a log, so that's the first thing that I write down. Then I look at my base. My base is 81 for this problem, so I write down 81. So that's log base 81. Then what does it equal? It equals 3. And remember, with my logarithms, I'm finding the exponent y, but they're not always going to be listed y. This one is listed w. And I've rewritten that exponential problem as a logarithm. And the point is not to find a numeric value. The point is to convert between exponent and logarithmic. Alright, so the next one, first thing I write down log. My base, they flipped it on us, right? So here's my base is 6, so log base 6. And what does it equal? My exponential function equals 1296, so log base 6 of 1296 equals my exponent up here, equals 4. And that is how I convert an exponent equation, exponential equation, to a logarithmic equation. Alright, let's look at one other. With this one, we're going to take our logarithmic equation and we're going to convert it to exponential. We're going to convert it to exponential. So 2 examples done for you here. And I went ahead and color coded, wrote the log in green, my base in red, and my x in blue. So my base, my exponent, what it equals. See, that's where it kind of gets a little tricky because they kind of switch the stuff around with logarithms. Log base 10 of 0.1 equals a negative 1. So in green, in red, and blue, my base, what does it equal? Negative 1. And then there's my x value in blue. So what I would like you to do, pause the video and answer these, and let's see if we end up with the same answer. Okay, so how I work it, the first thing I do is I look at what base my logarithm is to. It's to the fourth. I know that what a logarithmic equation equals over here is the exponent of that base, and it equals a number there. And most of these, unless they give you some odd numbers, most of these you can easily plug into your calculator. Say 4 to the fifth. Okay, yes. So I've rewritten that correctly. It's whenever they add in variables or weird numbers. But if you're ever in doubt, write a simple logarithmic equation or exponential equation where you know the values and then plug those in. Just don't do 2 squared, because 2 times 2 and 2 squared are the same thing. Pick something like 3 to the third, 3 to the fourth. Okay, for this one, my base is 16, so I write down 16. I know that what my logarithmic equation equals is my exponent, 1/2, and this makes sense. The square root of 16 equals 4. Okay, guys, watch the publisher's videos, critically think and structure your homework, and good luck on your remaining homework problems.